Lesson 34, scalar and matrix multiplication. What I wanted to do is wanted to show you we will be able to perform both scalar and matrix multiplication in the same question. Now, I just wanted to give a quick shout out to this question because this question does show up in the in exercise 5E. So I thought, well, it'd be a good idea to maybe talk about it so you guys can see how you might do it. Before I do that, let's have a quick refresh of what we did last week, last lesson. Last lesson, we did this big idea of matrix multiplication. Matrix multiplication has two major rules. The first is that you can only multiply them if the columns of the first matrix are the same as the rows in the second matrix. And that means that these two numbers in the middle, they must match. The resultant matrix, the matrix that comes out at the end, is the columns of the first times the rows of the second. That's how big the final one is. We use that to check to see which one of these would work and which ones wouldn't work. Then the rule 2, which I haven't made a formal slide for yet, so it's still scribbling, is matrix multiplication is non-commutable. That means that you can multiply A times B, but you can't multiply, in this example, B times A. It just can't be done. And the reason it can't be done is because they're not the same order the other way. And so I said A times B does not always equal B times A. It's just a rule. Sometimes they might if you're lucky, but usually they won't. So just be careful with that. We said the method of doing the matrix multiplication is run then dive. I'm going to do an example of this in a second, but we did that for these examples here. We then finished up with a quick video, which I said was a great resource of another way to do these problems. Maybe you guys like that other way. If you want to do that other way, go nuts. And then we did raising to a power. And raising to a power just means when you take the same matrix and you multiply it by itself. It's not as simple as just squaring every individual term. We're going to do scalar and matrix multiplication. And the example we're going to do is this guy here. And we're going to work on this together. We're going to pull out an answer. It's 3a times 2b. Now here's the issue though. It's not a times b as in matrix A times matrix B. It's 3 times matrix A times 2 times matrix B. First things first, is it doable? Let's just check that. Well, this is a 2 by 2 matrix. And this is a 2 by 2 matrix. So therefore 2, 2, it can be done. So how do we do this? Well, this is how I would do it. I would do the first step is I work out what 3a is. Now 3a, that's going to be 3 times the matrix 2, 3, 3, 1. And if you remember, when we multiply by a scalar, each term gets multiplied by 3. That's going to give us 6 times 3 times 2 is 6, 3 times 3 is 9. 3 times 3 is 9, 3. And then we're going to work out 2b. Now 2b happens to be 2 times 1, negative 1, 2, 5, which is going to be 2, negative 2, 4, 10. Just by multiplying each of these by 2. Now for the big one. And now I'm realizing that I probably made some mistakes here because these numbers are quite large, so it's going to be painful, but we're going to try and do it anyway because, you know, it's Friday. Let's give it a crack. 3a times 2b is going to be the same as 6, 9, 9, 3 multiplied by, I hope you guys are good at your 6 times tables, 2, negative 2, 4, 10. All right, here we go. So, you know the resultant matrix is going to be a 2 by 2 matrix. I'm going to skip a couple of steps, and you'll see why in a sec. You'll see how in a sec. But I'm going to jump to the second step down, and I'll explain what I mean by that. Let's do in red the rows times the columns. First row times the first column. Okay, 2 times 6 is 12. And 9 times 4 is 36. So I'm not going to do 9 times 4. That's what I'm saying. I'm just going to jump to the additions. Okay, that's it for that first one. Cool. Second one, let's go with green. Let's go for the first row for the second column. So first row, second column is this digit here. It matches because it's the first row and it's the second column. Whereas this is the first row and the first column. So that's going to be 6 times -2, which is -12. And we've got 9 times 10. We've got -12 plus 90. Now, the next one, let's go with blue. Second row, first column. 9 times 2 is going to give us 18. 3 times 4 is going to give us 12. Beautiful. Last one. Second row, second column, second row, second column here. That's going to be 9 times -2 is -18, plus 3 times 10 is going to be 30. Done. To be honest with you, that's the hard part, is getting them all into a nice little package here. Okay, if I then go 12 plus 36, well, that's going to give us 48. Beautiful. -12 plus 90 is the same as saying 90 take away 12, which is, sorry, my dog's barking, so it's a bit distracting. Sorry, 78. I was just realized that I was trying to talk over her. And I'm like, well, I'm trying to talk over her, and that's going to be a bit difficult. 18 plus 12, that's going to give us 30. The last one is -18 plus 30 is going to give us 12. Look at that. It's kind of cool because it's this is 18 plus 12 equals 30, whereas they have the same numbers. I don't know. For some reason, we might be able to see why that's the case. I can't. Oh, it's because, see how this is 6, 9, and this is 3. No, it's not too difficult to sort of see why, but I can sort of tell that because the numbers are similar, that's why we get similar numbers all the way through. And that's pretty much it. That's all I wanted to show you guys today. It was a nice, simple, quick little example here. The idea, I guess, is that you can mix the two things together. Now, I did the scalar multiplication before I did the matrix multiplication, and that's because usually, I guess, you would do a scalar multiplication first. It's sort of like a BODMAS thing, except for matrices, but it's a bit unique. Now, if I had something like this, I would do the matrix multiplication first and then multiply by 3. So that would be a bit different. So it's a bit like BODMAS here. The reason I did that is you will find in 5E, I think it's question 3, there's one example like this, just so that when you hit that question, you know what you're doing. Here it is here. The other reason why I mostly did this is because it gives me a quick chance to practice scalar multiplication and then to practice matrix multiplication. And if you missed out how to do that from the past couple lessons, you now have a refresher.